Hello everyone. This video is on section 10.4 part 2 titled Using the Properties of Logarithms. In this video I'm going to be going over a version of the Knewton Alta assignment for section 10.4 part 2. Please understand that the questions I see in this video may not be the same questions you see when you're working on the assignment yourself. But the objectives will be the same, the types of questions should be similar, so I'm hoping that watching me do these several problems here will help you in some way when you work on the assignment yourself. Alright, so here's the assignment page. You will not see the words preview of, you'll just see the title of the assignment. You have your mastery bar, telling you how far along you've gotten. Then you have your objectives. Now it looks like there are 3 objectives in this particular assignment. And then beneath the current objective, there should be a question related to that objective. And then beneath each question, at the bottom of the box, should be a feedback button, which you can send feedback to Knewton with if you wish. You will not see this instructor cheat button, right? That will not be there for you. But you will see a more instruction button, which you can click on and be provided with further reading material and or videos related to the current objective, and hopefully those help. Alright, so this first question is on the objective, use the change of base formula for logarithms. Alright, so before I get into this question, I want to write out this change of base formula for you. It's just one more property of logarithms. Now, I'm hoping that you watched the section 10.4 part 1 video, because in that video I went over, some other basic properties of logarithms, right? The product property, the quotient property, the power property, and others. And I'm going to just refresh your memory of those right now. All right. So properties of logarithms, just to recap from section 10.4 part 1, and we had the product property, where if you had the logarithm of a product, you could express that as the sum of 2 logarithms, the log of each factor added together. And if, in the other way around, if you see the sum of 2 logarithms, you can put it together as a single log of a product. The quotient property, the logarithm of a quotient, a fraction, is equivalent to the log of the numerator minus the log of the denominator, right? The difference of 2 logs. And then the other way around is, if you see the difference of 2 logarithms, you can put it together as a single log of a fraction. Then you have the power property, where you have the log of a power, or the log of some expression raised to a single power. You can pull that power out and make it a product. That's equal to that power times the log of just the base. Just x. And the other way around is, if you see a number multiplied by a logarithm, you can put that number inside as the power on the argument. And then some more properties that were discussed in section 10.4 part 1. Remember, the log base b of 1 is always 0. Log base b of b, right, these two numbers are the same, is 1, right, since any number to the first power is itself. And then you have what were called the inverse properties. The log base b of b to the x power was just x. Right, the log base b and this base of b kind of undid one another, and you're left with just the exponent there. And then the other way around, if I compose, exponential and logarithmic functions in the other way, we have b raised to a logarithm base b of x is just x again. Right? They kind of undo one another, this base b and log base b, and you're left with the argument of the logarithm. All right, so again, I went over these in section 10.4 part 1 as well. Now we are going to use the product, quotient, and power properties quite extensively in this section 10.4 part 2 also. So I'll keep referring back to these. Right. But now we're introduced to a new rule, right? One last property of logarithms here, called the change. They're calling the change of base formula. All right, the change of base formula. All right. So this is, if I take the log, if I'm trying to evaluate the log base b of some number, say of x, all right, so I'm starting off over here with an expression of logarithms, in base b. Well, if that's a base you don't like working with for some reason, we can change it. Say the log base b of x, just change the base to some other base. This is equivalent to the log base c of x. But there's some consequences to this. Right? You can't just change the base and have them be equal. Right? After you change the base from b to c, then you have to divide by the log of the original base. So log base c again, right? We change from base b to base c, but now the argument of this denominator log is the original base, right? This was base b here. That becomes the argument, the input of this denominator log with this new base c. Right? So the logs on this side are base c. Now, usually we'll do either base e or 10. Right? Those are pretty easy because most calculators have log base e, which is that natural log, the ln button, and also have the log base 10 or just log button. Right? Yeah, this is called the change of base formula. So for example, right, the very first question we're given in this assignment is, they're asking us to rewrite the log base 4 of 10 as a quotient of natural logarithms. Right, so right now, this is an expression where it's a logarithm with a base of 4, and they're asking us to change to base e, change to natural logarithms, right? Change to base e, right? So just change the base first off. Instead of log base 4 of 10, we do the natural log of 10, right? But these aren't equal, right? I'll show you on a calculator in a second. So then after you change the base, right, so instead of log base 4 of 10, now I'm taking the log base e of 10, then you divide by the log of the new base, log base e, of the original base, right? The original base was 4. That goes inside this denominator log. And this is what they want, right? Now let me show you that these are actually the same. All right, let me pull up a calculator, and I have a TI-84 Plus emulator here. And I'm going to enter these two expressions. Right, the log base 4 of 10, which for this I have to hit the math button, go down to log base, put the base of 4, and then the argument of 10. All right, so you're going to see the log base 4 of 10 is 1 point something, 1.660964047, blah 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 blah. Right? And now let me enter this, after using the change of base rule to change it from a base 4 expression to a quotient of a base e expressions. I said this would be the, just take natural log of 10, all right, log base e of 10, and then divide that by the log base e of the original base. And you'll see that this ends up giving me the same number. These are the same value, 1.66096. Blah, blah, blah. Now, you didn't have to change it to base e. I know they wanted us to change it to base e though, but you can change it to any base you wish. All right, any base you wish. And that's why I have base, in the formula, base b on one side and base c on the other. Right? You can change it to any base you want. But here is, base e. Okay, so let's get rid of the calculator there. Now, so back on the assignment, I'm just entering log base 4 of 10 as the natural log of 10 divided by the natural log of 4, and those are, as you saw in the calculator, the same value. Now they already have the ln, so I'm just entering the arguments, natural log of 10 in the numerator, natural log of the original base 4 in the denominator. Okay, great. And then after every question, there should be some sort of answer explanation. Please read through these. Okay. If you got it correct, just read through it. Make sure you got it right for the right reasons. That you didn't just get lucky. Or maybe they have some sort of alternate method to do something that you like better and you might use for future questions. Now, if you got it wrong, definitely read through the answer explanations. Try to figure out why you were wrong, and hopefully you can learn from your mistakes. Okay, next question. Alright, so this one, we are asked to use the properties of logarithms, mostly the product, quotient, and power properties, to expand a logarithmic expression. Alright, so it says here, use the properties of logarithms to expand the logarithm, and then simplify any if possible. Note, if you are using log, you need to type it in and use the subscript button on the keyboard, right? There is no log button. So we have to type in the word log and then use subscripts to put in log base 3 here. Alright, so I'm going to write this log out and talk about what we're doing here to expand a logarithm. Alright. Okay. So when we're asked to expand a logarithm, that just means use the product, quotient, and power properties until you can't use them anymore. Use the product, quotient, and power properties until you can't use them anymore. Alright. So here, you just keep looking inside the logarithm. You keep looking at the argument and ask yourself, does it fit one of these properties here? Does it fit is the argument a product, a fraction, a quotient, has one numerator, one denominator, or is it all to a single power? And if the answer is yes, then you can use one of these properties. If the answer is no to all three, then you're finished. Alright, so I've already refreshed you, what the properties are. Now looking at this, I look at the argument here. This is clearly a fraction, a quotient, right? So I'm going to be using the quotient property to start. And something I like doing, and you're going to have to do as well, and you saw this in section 10.4 part 1 too, right? Part 1 also. When you see roots, when you see radical symbols, remember, those are powers. The square root is really the 1/2 power, right? The cube root is really the 1/3 power. So I'm going to start rewriting that as a power. Okay, so first I'm using the quotient property. Now remember, the log of a quotient is the log of the numerator, so log base 3 of, now the numerator is, 3x plus 2y squared, all of that, the radicand, to the 1/2 power. Alright, instead of the square root. Please do this, right? When you see radical symbols, rewrite them as, fraction powers. Then minus the log of the denominator. The log base 3 of the denominator is, 5z squared. Okay? And then I keep going. Look inside every single log that we create. Every single log we write. So inside this logarithm, notice that the entire expression is raised to a single power. So I can use the power property on this one. This one, however, yeah, there's a power, but is everything inside raised to the second power? No, the 5's not raised to the second power. So I can't use the power property for this logarithm, but I can use the product property. Right? That's 5 times z squared. Alright, so I'll do that. Now remember, the power property is you basically just take that power and put it in front. So this is 1/2 times the log base 3 of, and then the power's gone, and then what's left over is the base, 3x plus 2y squared. Alright, so I'm done with that one. Then we have minus. Now be careful. Remember, the log of a product becomes the sum of two logs. Right? Saw that here. The log of a product becomes the sum of two logs, has two terms. So be careful with subtraction. I'm subtracting this log of a product, meaning I'm going to subtract both terms. So I'm going to put parentheses here. Alright, we're not just subtracting the first of these two terms, we're subtracting all of it. So in parentheses, the log base 3 of 5z squared could be written as the log base 3 of 5 plus, right, the log of a product is the sum of logs, the log base 3 of z squared. And then close parentheses, right? We are subtracting all of this. So in fact, I'll do that right now, where I'll distribute the negative. Right? I'll distribute the negative, and then we have the following. So we have 1/2 times the log base 3 of 3x plus 2y squared, and then minus the log base 3 of 5 minus, right, minus a plus here, minus the log base 3 of z squared. Alright, and now I look inside the logs again. 3x plus 2y squared. This is a sum, not a product. It's not a product, it's not a fraction, and it's not all raised to 1 power. So I'm done with that one. Look inside this log. The argument's just 5. That is not a product, it's not a fraction, and it's not all raised to a power. So I'm done with that one as well. And I look inside this one, z squared. See how the entire argument here is raised to a single power. So I can apply the power property. Alright, so just one more and I should be done. So in the very end here, I have 1/2 times the log base 3 of 3x plus 2y squared, right, that one was finished, minus the log base 3 of 5, minus, and then remember what happens with the power, that power that the entire argument's raised to just comes out front, minus 2 times the log base 3 of just z now, right, the power came out. And now all of these are done. Right? So I'm just going to put this in a box. This is what we're going to enter. Right, this is what we're going to enter. So I've started with this logarithm here, and then just kept looking inside the logs, kept using this product, quotient, and power property until I couldn't use them anymore. Right? All these arguments in the end are not products, they're not quotients, they're not all raised to a single power. So I'm finished. Alright, so I'll enter this back in the assignment. Alright, so we have a totally blank space. We have 1/2 times the log base 3, right? Go to the subscript of, and then we had inside that first log there 3x plus 2y squared. Okay, then minus the log subscript 3, log base 3 of 5, then minus 2 times the log base 3 of z. Right? And that was everything I wrote out on my paper. And this should be good. I can't use the product, quotient, or power properties anymore. Wonderful. All right, once again, after every question, please read through the answer explanations. All right. Great. Next question. Same concept. All right, use the properties of logarithms to expand a logarithmic expression. There's one other property where we're going to contract. You're going to take, it's basically just doing this in reverse. You take a ln expression with logarithms and write it as a single logarithm using the product, quotient, and power properties, but in reverse. All right, but here we're asked to expand. So again, I'm going to write this logarithm out, and we'll keep expanding. And once again, you see the fourth root there, and you make that into a power. Okay, so first I see this fourth root of everything. So I'm going to make this the log base 2 of the radicand here, right, which is 5x cubed divided by 2y squared z to the fourth. That to the 1/4 power. All right. Now I look at this and I say, hey, I can use the power property, right? Because the entire argument is raised to a single power here, this 1/4 power. All right, so I pull the 1/4 out front. So this is equal to 1/4 times the log base 2, and then the power is gone, and then we have 5x cubed divided by 2y squared z to the fourth. All right, and now I look at this argument, and that is clearly a fraction, right? A quotient, one numerator, one denominator. So I'm going to be using the quotient property here. Now, just as with the the product property in the last example, be careful. The quotient property turns one log into the difference of two logs. So something with one term into something with two terms. And this is being multiplied by 1/4. So right now I have 1/4 times the one term, but that 1/4, right, should be multiplied by everything. So I'm going to put this in brackets or parentheses. 1/4 times whatever log base 2 of this is equal to. And it'll be log base 2 of the numerator, 5x cubed, minus the log base 2 of the denominator, 2y squared z to the fourth. Okay. And then if you want to put the 1/4 in, you can. I'm going to leave it in brackets for now, though. All right, we'll do it at the end. All right, and then in both of these arguments, I have products. And be careful with subtraction, right? Now here there are three factors, 2, y squared, and z to the fourth. So I'm going to write this as the sum of 3 logs. All right, 1 for each factor. And we're subtracting all of that. So I'm going to have, nested parentheses here, nested brackets. So we have 1/4 times the quantity. This log base 2 of 5x cubed, I'm going to write as the log base 2 of 5 plus the log base 2 of x cubed. All right. Then we have minus, remember, minus the quantity, right? This has 3 terms. Minus the quantity, you're subtracting all of this, not just the first term. The log base 2 of 2 plus the log base 2 of y squared plus the log base 2 of z to the 4th. Right, close parentheses, close brackets. All right, so I'm going to distribute the negative here. All right, I'm going to distribute the negative, and we can simplify the log base 2 of 2. Right? The log base 2 of 2 is just 1. Right? Log base 2 of 2 is just 1. And I'll distribute the minus sign here. Right? Distribute the minus. So we have 1/4 times the quantity. Now the log base 2 of 5 is just going to stay that way. Log base 2 of 5. And then with the log base 2 of x cubed, I can use the power rule. And in fact, I can use the power property for the x cubed one, the y squared one, and the z to the 4th. I can use it for all 3 of those, because every single one of those arguments is all raised to a single power. So plus, the log base 2 of x to the 3rd, you pull the 3 out, it'd be 3 times the log base 2 of x. We have minus 1, right, minus 1, minus, and then 2 times the log base 2 of y, and then minus, and then 4 times the log base 2 of z. Okay, and then close the brackets. And now I will distribute the 1/4. All right. Now I'll distribute the 1/4 to all this stuff. So this is 1/4. You know what? I'm actually going to leave it like this. No. I should put it in. Sorry. So 1/4 times the log base 2 of 5 plus 3/4 times the log base 2 of x minus 1/4, and then a 4th times negative 2 here would be minus a half times the log base 2 of y, and then 1/4 times negative 4 is minus 1, so just minus the log base 2 of z. And this, I know it's crazy, it's long, but this is it. This is the as far as I can go. I can't use the product, quotient, or power properties anymore. Look at all the arguments. Right? And that's what I'll enter, this crazy long expression at the end here. All right, so back in the assignment, I am entering 1/4 times the log base 2. Don't forget the subscripts, right? Don't forget your bases. Oops. Log base 2 of 5 plus 3/4 times the log base 2 of x minus 1/4 minus 1/2 times the log base 2 of y, and then minus the log base 2 of z. Be careful with the letters. All right. And that should be good. Just double checking what I wrote on the paper here, making sure it all matches up. And that should be equivalent to the initial expression as well. Great. All right, and please read through the answer explanations. You saw that one took a few steps. It can be a bit complicated. Oh, they did leave it with the quarter outside. How nice of them. So I could have left it with the quarter outside instead of distributing the 1/4. Great. All right, next question. All right, so we're back to that change of base rule, which I'll bring up again. And we're asked to use the change of base formula to approximate the log base 2 of 77. Right. And round to 3 decimal places. So a calculator is going to come into play here. But another example, right? We have the log base 2 of 77. Now 2 to the 2 to the 5th power is 32, 2 to the 6th power is 64, 2 to the 7th power is 128. So 2 to the 6th power is 64, and this is a little bigger than that. So this is going to be 6 point something. This is going to be between 6 and 7. But we're going to use a calculator to get this to 3 decimal places. Now they do ask us to use the change of base formula. You saw on my calculator though, I can use just the base 2 as is. But say you don't have a base 2 button, right? Say you just have a base 10 or a base E. Well, I can change this to base 10 if I want. Instead of log base 2 of 77, let's take the log base 10, just log of 77, but then don't forget to divide by this new log of the original base, right? In the denominator I have the log base 10 of 2. So let me enter this, and we're going to round this to 3 decimal places, right? And again, I said it should be between 6 and 7. All right, so let's pull the calculator back up. So I'm taking the log base 10 of 77 divided by the log base 10 of the original base, which was 2. And you see it's approximately 3 decimal places would be 267, right? Because it's 266, and then the 4th decimal place is 5 or more, so I'm going to bump that up to 267. And if you want to check that, all right, check that. If this is true, then 2 to this power should be 77, right? 2 raised to that previous answer, 2 raised to the 6.266 of the power, should be 77, and it is. So that does work. Okay, so let's get rid of the calculator, and I'm gonna enter it to 3 decimal places though, rounded to 3 decimal places, 6.267. 6.267. Great. All right, once again, read through the answer explanations, please. Next question. All right, so now, instead of expanding, we are asked to condense a logarithmic expression. So you're going to get a logarithmic expression with multiple terms and asked to write it as a single logarithm. All right. All right, so this is just reversing the expansion process. So if you remember, I've only done 2 of them so far, but in all those expansion examples I've done, the last property used was usually the power property. So that's going to be the first thing I use here. All right, we're going to try to write this as a single logarithm, and then they did ask us to simplify the expression at the end if possible. So any numbers, see here I have 2 times the log, right? A number times a log. We could put that number inside as a power, right? So I'm going to start off by using power rule. power property. So this is equal to the log base 3 of, x squared minus 1 minus, and then putting this in as the power here, we have the log base 3 of, this whole thing to the second power. So the whole quantity, x minus 1 to the second. Okay. So first I'm reversing the power rules, right, or using the power property. And then I go from left to right, unless there are parentheses or something. But go from left to right and then just use the quotient properties and product property as you need them. All right. So here, these two, see, this is a difference of logarithms with the same base, log minus log. So I'm going to be using that quotient property to put them together. All right. Now if it were a sum, I'd be using the product property to put them together. Now remember how this goes. Log minus log becomes a single log, log base 3 of, and then what's inside the log is just a fraction. It's, the first argument is the numerator divided by, and then the second argument is the denominator, right, the quantity x minus 1 squared. All right, but then we are also asked to simplify the expression. This is what they want, right? They want a single logarithm, which is what I have here. But now if we can, let's simplify this expression, which is just a rational expression in here. I'll take it off to the side. We got x squared minus 1 in the numerator. And then, the denominator is already factored. Remember how to simplify a fraction of polynomials, right? You factor the numerator and factor the denominator and cancel any common factors that they might have. X squared minus 1 is a difference of squares. That factors to x minus 1 times x plus 1. And the denominator is still x minus 1 squared. And there's some common factors here. There's just the x minus 1s, right? But only one of them, right? So there's still one x minus 1 in the denominator. So after totally simplifying the fraction, we have the log base 3, right? A single logarithm. And now this expression inside the argument is x plus 1 in the numerator. All right, that's the only factor left. Divided by, and then the only factor left in the denominator is x minus 1. And there you go. All right, this is what they want. Take the expression we were given initially with multiple terms with logarithms and write it as a single logarithm with a simplified argument. All right, so this is what I'm going to be entering in the assignment. The log base 3 of x plus 1 divided by x minus 1. Alright, so they already have the log base 3 written for us. I just need to enter the fraction inside, right? X plus 1 divided by x minus 1. Right? Notice I put parentheses around the numerator because it has multiple terms, and that should be good. Excellent. Alright, so yeah, this is just reversing the expansion process, right? We're condensing, writing an expression as a single logarithm with a simplified argument. Great. Next question. Alright, so again we're on this property of condensing a logarithm. Alright, so I'll write this out. We're going to use that power property first, right? Take any numbers multiplied by a logarithm, like the 1/3 and the 3, and put them inside as powers of the argument. Alright, so once again here, all these numbers multiplied by the logarithms, the 1/3 and the 3, right? Ignore the negative signs. Ignore the negative signs, just the 1/3 and the 3. I put those in as powers, so this is the log of x to the 1/3 power. And if you'd like, you could write this as the cube root of x. Right? And it's the same thing, x to the 1/3 power. Minus, and then put the 3 inside here, we have the log of, and then remember, it's the entire expression to that single power, so the quantity x plus 1 cubed. And then you go from left to right and use the product property or quotient property as needed. And you're seeing these two here. This is a difference. So I'm using the quotient property. Right? So log minus log is going to be a single log of a quotient, where the first argument's the numerator. Right? So x to the 1/3, or if you want to write the cube root of x, that's fine too. And the second argument, the quantity x plus 1 cubed, is the denominator. And this is as simple as that expression gets. There are no common factors in the numerator and denominator, and that's it. I have expressed my original expression as a single logarithm with a simplified argument. Alright, so that's what I'll enter back in the assignment. Right, so now they already gave us the log, the single log. We just have to enter the argument. Right? It would be x to the 1/3 power, get out of there, divided by the quantity x plus 1 cubed. Right? And that should be good, unless they want us to enter the cube root of x, but that should be enough. Yeah, see, they changed it to the cube root of x, but it's the same thing as x to the 1/3. Right? Wonderful. All right, next question. All right, so we're back to that change of base formula. Now this time I'm just going to pull a calculator up. We are asked to evaluate the log base 3 of 24. I'm just going to change that to natural log base e. It doesn't matter. Log base e, log base 10, it doesn't matter. So we want the log base 3 of 24, so how about just the log base 10 of 24? But then divided by the log base 10 of the original base, which was 3. Alright, and this should be 2 point something. Right. And then just to check it out, take the base 3 raised to this power should be 24, and it is. Right. So 2.8927, so 2.893, right? 2.893 when I round to 3 decimal places. Right, so 2.893. And that's it. Right, pretty easy, those change of base formulas, I'm hoping. Great. Alright, looks like we got just one more of these. So once again, I'm just going to pull up the calculator, and we're asked to do the log base 9 of 20 rounded to 3 decimal places. So this is going to be 1 point something, right? Because 9 to the first is 9, 9 squared is 81, which is bigger than 20. So this is going to be 1 point something. Alright, so we pull that calculator back up. Now we're asked for the log base 9 of 20. So again, I'll just change it to, let's do the log base e of 20 instead, but then divide by the log base e, that natural log, of the original base, which was 9. Right? And this should be, again, 1 point something. 1.3634, so 1.363. 1.363 when I go back to the assignment. All right, and again, if you want to test it out, 9 to this power should be close to 20, right? I say close to 20 because this is rounded. Great. All right, so that objective's done. That was that was probably the easiest of the 3 objectives, the change of base rule. All right, next question. All right, we're back to the use properties to expand. All right, and so you've seen me do a couple of these, right? So this is where you're using the product property, the quotient property, and the power property until you can't use them anymore. So I'll write this out, and I'll do it, probably a little more quickly than I've done the other ones. All right, so this is a fraction. So I'm going to use the quotient rule first. So I'm writing this as a difference of logs, log base 2 of the numerator. Now the numerator, again, anytime you see a root, I'm going to write it as a power. That's 2x, the quantity 2x plus y squared. and instead of the square root of that, that's to the 1/2 power. All right, same thing. Minus the log base 2 of the denominator, right, of z squared. And then in both of these I can use the power rule, right? Everything in here is raised to the 1/2 power, I can pull that out. Everything in this argument is raised to the 2nd power, I can pull that out. Then I apply the power rules. We have this is equal to 1/2 times the log base 2 of 2x plus y squared. Minus, and then 2 times the log base 2 of just z. And I'm done. This argument is not a product, it's a sum. It's a sum. And there was no log of a sum property. Right? It's not a product, it's not a quotient, it's not all raised to, yeah, there's a power of 2 in here, but it's not all raised to the 2nd power, so I can't use the power rule. So that's it. Right, that's what I'm entering. It's back here. The expanded expression is 1/2 times the log base 2, don't forget your subscripts for the bases, of 2x plus y squared in the superscript. Oops. Get out of there. Then minus 2 times the log base 2 of z. Right. Just make sure that that matches what I wrote in my paper, and great, it does. Submit. Fantastic. All right. So next question. All right, we're expanding one more time here. So again, I'll write this out and go through the expansions again, probably a little more quickly than I did the first 2 examples of this. Alright, so just like an earlier problem, right, this whole thing is, you're taking the cube root of it. So that's log base 5 of, and then this radicand here, this whole thing, 3x squared divided by 4y cubed z. Right, this is being raised to the 1/3 power. Same thing as the cube root. Right? And then I can apply the power rule, power property, and pull that 1/3 out front. So this is equal to 1/3 times the log base 5 of, and then the fraction 3x squared over 4y cubed z. Right? And then I say, hey, this is a fraction. So I can write it as the difference of 2 logs. Now don't forget, everything is being multiplied by 1/3. Right? 1/3 times this whole log. So it's 1/3 times the quantity, and then log of the numerator. Right, log base 5 of 3x squared minus the log of the denominator, the log base 5 of 4y cubed z. Alright, and then this is a product. This is a product of 3 factors, so I'm going to write those as logs of sums. So we have 1/3 times the quantity. This log base 5 of 3x squared I can break up into log base 5 of 3 plus the log base 5 of x squared. Then we have minus, and it's going to be minus a whole big sum. Maybe the log of 4 plus the log of y cubed plus the log of z, but then we're going to distribute the negative. So I'm just going to make them all minus. So minus the log base 5 of 4 minus the log base 5 of y cubed minus the log base 5 of z. And once again, that's because this became a sum, but we're distributing the negative, right? We're subtracting all those terms. I hope that made sense. And then all I have left are powers. Pull the 2 out, pull this 3 out, and then I'm done. All right, so I'm just going to write it this way. 1/3 times the quantity, log base 5 of 3, plus, and then 2 times the log base 5 of x, minus the log base 5 of 4, minus 3 times the log base 5 of y, and then minus the log base 5 of z. All right, and this is the way I'll enter it this time. Instead of, you can distribute the 1/3. You can put the 1/3 on all these terms, but I'm just going to leave it this way. All right. Yeah, so I can't use, you could call 4 2 squared and use the power rule again if you want, but I'm not gonna. All right. For all these arguments, I can't use the power rule, quotient rule, product property anymore. Okay, so we got 1/3 times the quantity, right? Set parentheses here. Log base 5 of 3 plus 2 times the log base 5 of x minus the log base 5 of 4. Now they might want me to put the log base 5 of 3 and the minus log base 5 of 4 together because those are constants, but I'll just leave it the way it is right now. Minus 3 times the log base 5 of y, and then minus the log base 5 of z, and then close parentheses, right? So that all is multiplied by the 1/3. Great. All right, again, please read through your answer explanations. All right, then all we'll have to do now is the condensing, right? Just reversing this, taking something like I have here at the end and going backwards to write it as a single log like I started with in the beginning. So again, I'll write this expression out. Oh, they're even telling you to use the power property, but I've been mentioning that, right? I'm starting, when I'm doing these condensings, I'm starting with the power property. Any number multiplied by a logarithm I'm putting inside as the power of the argument. Alright, so this 2, this 1/2, I'm going to put those inside as powers of the arguments. So this is equal to the log of, and then the entire argument, 2x plus 3, in parentheses, raised to the second power. Plus, and then here put the 1/2 inside, we have the log of, and then the entire argument, x plus 1, to the 1/2 power. Or if you want, you can write that as the square root of x plus 1. Same thing, right, to the 1/2 power. And now I have the sum of two logs. Right, sum. So when I put them together as a single log, right, that's the log of a product. Right, so these two put together make the log, right, single log of the product of these two arguments. So the quantity 2x plus 3 squared times the quantity x plus 1 to the 1/2, or the square root of x plus 1 if you want. And that is all we're doing. This doesn't simplify any further. If you want to multiply things out, fine, but I'm not going to do that. And we have a single logarithm. That's all they want. So back here, now they already gave us the single log, right? It's just a single log. We just have to enter the argument, right? The quantity 2x plus 3 squared times the quantity right next to it, x plus 1 to the 1/2, right? The 1/2 power, or the square root of x plus 1 if you want to put that in as well, right? Great. All right, we should have just one more like this condensing a logarithm, a logarithmic expression. All right. So this one has 3 terms, but same stuff, right? I'm going through the same stuff. All right, so same procedure. All these numbers, the 4, the 2, and the 3, I'm going to put in as powers. So this is equal to the log of x to the 4th minus the log of y to the 2nd minus the log of z to the 3rd. All right, and then I'm just going left to right here, 2 at a time. 2 at a time. First 2 terms I see as a difference. So that's the log of a fraction, the log of a quotient. Right? So this is the log of x to the fourth divided by y squared. Right? And then we still have minus the log of z cubed. All right. And then, again, two terms. Difference. So this is the log of a quotient. This is the log of, x to the fourth over y squared, right, divided by z cubed. Now this is ugly looking. All right, this is kind of ugly. But remember, dividing by z cubed, so x to the fourth, divided by y squared. Dividing by z cubed is the same thing as multiplying by 1 over z cubed. I hope you remember that. Right? Division is the same thing as multiplying by the reciprocal. So this expression in here is actually just x to the fourth in the numerator and then y squared z cubed in the denominator. So we have the log of x to the fourth times 1, or x to the fourth in the numerator, and then y squared z cubed, y squared times z cubed in the denominator. And there's our final log. All right, a single log of a nice simple, this can't be simplified any further, of a simplified argument. Yeah, so it's use the power rule, put some numbers inside as powers, then going from left to right, taking two terms at a time. If it's a sum, you're using the product rule. If it's a difference like these were, you're using the quotient rule, quotient property. All right, now they gave us the single log already, and we just have to enter the argument, right? The numerator was x to the fourth, divided by, and the denominator of this argument was y squared times z cubed. And that should be good. Wonderful. All right. And again, please read through answer explanations. Okay, and that should be it for this particular version of this assignment. As I said at the top of the video, right, just understand that the questions I saw here might not be the same questions, most likely won't be the same questions you see when you work on the assignment yourself. But the objectives are the same, the types of questions should be similar. So I'm hoping that watching me go through these 12 questions here help you in some way when you're working on the assignment on your own. And thank you very much for watching.